Welcome to Wednesday, with this one being the day after Election Day. But we are currently in the middle of Picture Book Month. Now, while we won't be talking about any picture books on this webinar, we will be talking about a code book that has a few drawings and visual aids. Too much of a stretch, maybe? All right. So what are we talking about? Well, we're going to be taking a look at what we can expect to see in the next edition of the International Energy Conservation Code, or IECC for short, and we're going to look at residential buildings specifically. Now, we're going to look at things like what's changed from 2018 to 2021, and also what are the current trends. Now, stepping in for Shauna Mozingo, who had a family emergency, is Robby Schwarz. Robby has been a champion of applied building science for over 25 years. He's helped Colorado jurisdictions develop and implement their energy code, presented code language that was then later adopted at the National ICC code hearings, and encouraged implementation of third-party inspection and building performance compliance. Robby is also a code trainer for groups such as the Colorado Energy Office, the Colorado chapter of the ICC, Nevada's Edu Code, and the Boulder County Marshall Fire Victims. Now, because of Robby's field work with builders, trade partners, and code officials implementing and verifying IECC requirements, he excels in explaining and demonstrating not only a code requirement, but the rationale and the building science behind the requirement. His focusing on a simple phrase such as, "Is it there and does it work?" has allowed Robby to be able to demonstrate the impact of implementing a code requirement on the performance of a house. Hey, sounds like it's perfect for today's presentation. Now, before we get started, I want to tell you about PowerShift by NV Energy. It's a program that helps residential and business customers conserve energy and save money on their power bills. PowerShift is a one-stop resource to find energy-efficient products and services. And for more information, you can visit their website at nvenergy.com/PowerShift. Now, during the course of today's presentation, you can submit questions for our guest. Simply use the questions box that you'll see probably on the right side of your screen in the GoToWebinar control panel. I'm going to review those questions and pose those to Robby during the Q&A time set aside after his presentation. Robby, my friend, welcome to the program.
Thanks so much. I appreciate it, Mike. And thanks for everyone for joining us today. As you can see, I am not Shauna Mozingo, as Mike said, but she called about an hour ago and asked if I could step in. So we're going to talk today about the significant changes in the IECC, so the differences between the 2021 and the 2018. I am going to turn off my video at this point because you would end up looking at the side of my head because I have another screen up where the presentation is. So we're just going to jump right in here and talk today. I'll talk a little bit about kind of this apocalyptic thinking about when we think about code changes and kind of this apocalyptic notion that some people have. We'll talk about what the reality is there. We'll kind of divide the significant changes into those things that really impact efficiency and those things that don't impact efficiency as much. And then ultimately, what does it mean to us who are involved in the code compliance arena here? So beginning with kind of like this apocalyptic moment, it really began with the 2021 IECC. The main reason people thought that the code change was going to be so significant was because in the 2012 IECC, this is when blower door testing became mandatory in the IECC. In the 2009 IECC, the preceding code, somehow there was a notion that you could mysteriously look at the house and tell how airtight it was. Because its threshold was set at 7 air changes per hour, maybe that wasn't that hard to do, but in the 2012 IECC, the thresholds for air tightness changed, especially in the colder climates, climate zones 3 through 8, at 3 air changes per hour, climate zones 1 and 2 at 5 air changes per hour. And people were pretty concerned about how we were actually going to achieve that level of air tightness, and also if we had the infrastructure to be able to do that there. The 2021 IECC to some also feels kind of like this apocalyptic moment, and that is coming to us again. And why is that the case? Well, because the Department of Energy did a determination that the 2021 IECC is going to be about a 10% increase in efficiency from the 2018 IECC. So let's talk a little bit about what that means. So after the code is written, the Department of Energy is charged with actually determining how efficient that code is in comparison to the last code cycle. So if we use the 2006 IECC as the reference point, going from the 2006 to the 2009 IECC, it was determined that was roughly a 15% increase in efficiency. Now, the first thing we have to know is that that determination happens with the unamended code. So the code as it was officially written and published by ICC, the International Code Council there. The next thing we need to think about is how did they achieve that 15% increase in efficiency? And that was gotten primarily on the back of increasing R values and U values in the building thermal envelope there. Now, moving from the 2009 to the 2012 IECC, the Department of Energy said, well, we got roughly another 15% increase in efficiency, and that was gotten on the back of air tightness. So we see conduction and convection, those building science principles of how energy moves from higher concentration to lower concentrations being taken care of it by the code in the 2009 and the 2012 IECC. Well, in the 2015 and 2018 IECC, we see that there was hardly an increase in efficiency achieved in these codes. Primarily, people wanted to give jurisdictions kind of a time to catch up to having to test their homes. Also, this caused a lot of kind of, I don't know if conflict is the right word, but consternation anyway, in the code development world about the direction, what's the proper direction of the energy codes here. And so things didn't change much in the 2015 and 2018 IECC. Basically, they're considered better written versions of the 2012. Every new released code is a better written version, but some increases the efficiency as well. And the 2021 IECC, the determination was that it was about a 10% increase in efficiency. So let's figure out how they got that 10% increase in efficiency. Let's just dive into that. So we're going to talk about this increase in efficiency from the changes that happened in the 2021 IECC from the perspective of those things that really impacted efficiencies and those things that really were kind of better written language and other things that promote and are part of the rationale for having this 3-year process of changing the codes. So starting with those things that impact the efficiency of the code, we have to understand that there's lots of flexibility built into the code. There are different compliance options, different compliance pathways that you can do, that you can take advantage of to build the house that you want to build, regardless of the code change. There are instances out there where people have been able to demonstrate that they haven't had to change the way that they build their homes from the 2018 IEC to the 2021 IECC and still demonstrate compliance. You might say that they've been doing more than what they had to do for the 2018 IECC, but really it's the proper choice of the compliance option that's the main issue there. So in the prescriptive section of the code, you have a variety of compliance options, and I'm dividing it up and separating the UA compliance option because the UA compliance option requires a software to help you determine if you're in compliance or not. The prescriptive U value and prescriptive R value tables haven't changed in terms of how you comply with it. Basically, thou shalt do what's listed in those tables. The prescriptive U value compliance and now begins to allow you to do some things that we call trade-offs. And the total building performance compliance option really leverages that idea of trade-offs. And then we have the energy rating index pathway that's been in the code since the 2015 IECC. Tropical climate zones was added in 2021. So if you happen to work in any jurisdiction that's in Hawaii or Guam or someplace like that, you might want to take a look at that. We're not going to focus on that, obviously, in this session here. And then regardless of the compliance pathway that you choose, there are these new additional energy efficiency requirements. And this is one of the ways that we got that 10% increase in efficiency from the 2018. What does this actually mean? Additional energy efficiency. So this section establishes what you have to do dependent on your compliance pathway through the code, what additional option you have to choose. So if you choose a prescriptive compliance option, you need to choose one of the efficiency packages that are laid out in chapter R408 or section R408 of the code. If you choose the total building performance, you also have an option here of choosing one of the efficiency packages that it can't be included in the energy model though. So you have to be conscious of what you're choosing and why you're choosing it there. Or you can choose a compliance option that demonstrates that your house is 5% better than it was normally. So better than the reference design in this case here. So I think we'll talk a little bit about how energy modeling works so that you can get an idea of how you're 5% better than. But choosing an option in this that does not impact the energy model means that we have to have an understanding that mechanical efficiencies aren't generally what the energy code is looking at. It's looking really at R values and protecting the thermal envelope efficiency there. So it's one of the efficiency options that you'll see here in a second is to increase the efficiency of our HVAC equipment, which is easy to do because it's not included in the energy model for the total building performance path or the prescriptive UA compliance path. It is included in the energy rating index pathway, however, and in that pathway, you only have the option of demonstrating that you're 5% better than here. So these are the actual efficiency options here that you can choose from. You can choose to enhance the building thermal envelope and make it more efficient. You can choose to have a higher efficiency HVAC equipment here. And this gets around what we call federal preemption because the federal government actually sets the minimum efficiency of mechanical equipment. But because you have these different choices, you're able to make a choice to include a system that's more efficient than the minimum federal efficiency there. And sorry for the typo here. I just realized that the 95%, it should say AFUE for annual fuel utilization efficiency, not AFUR there. You could also choose between water efficiency issues with higher efficiency water heaters, more efficient HVAC delivery systems, and improved air sealing and ventilation there. So those are basically your 5 choices that you can make depending on the compliance option that you actually want to do. So let's talk about those a little bit more depth. So if you're choosing your prescriptive compliance option here, you basically have 4 choices to choose from. You have a assembly U value approach that's detailed out in the code. You have an R value assembly approach. You have an R value cavity approach, which is the true R value table, and you have the area weighted U value trade-off approach. Now, most builders will only be looking at the cavity R value approach or the area weighted U value approach. The area weighted U value approach, again, needs a software. It's utilizing either the ResCheck software or an energy rating software like Ecotrope or RemRate would be examples of softwares that can demonstrate compliance using the area weighted U value approach. And the reason I bring that up is that a lot of people call the area weighted U value approach the ResCheck approach. And we just need to be crystal clear that ResCheck is a software that demonstrates compliance with the total UA compliance approach. It is not the name of the approach there. The assembly U value and the assembly R value approaches really are included in the in this section because they're needed for softwares to be able to do the energy model. So basically the assembly U value approach is, and the U values that are listed in the U value table are equivalent to the cavity R value approach here. So when we look at the cavity R values, the 2021 IECC, like every code that is looked at there, first, this table is about the cavity insulation. So when it says R20 in a wall cavity, it means the R20 of the insulation is the lowest R value that you can put in that cavity. The second thing that this table is pointing out is what is in red on this slide, and that is that the first edition of any code generally has mistakes in it. And so you need to go to the errata to make sure you have all the mistakes that have been caught so far fixed, you can fix in your edition of the code. Or if you only buy the online version, the online version gets updated every once in a while with things that have been pointed out that are incorrect in the original versions of the printed code, and those things will be changed. But this is an example of something that in version 1 of the printed code, these red items were not correct. And they're pretty important items here. For climate zone 5, for example, it just said 20 plus 5 continuous insulation. So the R30 wasn't there. The other options for your wood frame wasn't there. But you can see that this is the other way that that 10% increase from the 2018 to the 2021 IECC was achieved. So in climate zone 5, I'm focusing on climate zone 5 because that's the climate zone I'm in here in Denver on the Front Range of Colorado. You can see that ceiling R values were increased from R49 to 60. Wall R values were increased with by about 5 with continuous insulation, or the option of doing a double framed wall, for example, that R30 wall. Those were the main things that changed from the 2018 IECC. The other things really didn't change that much in my climate zone, but in other climate zones that could be different. So you want to double check and make sure you look at this table to see whatever climate zone you are building in, or you are inspecting in, or enforcing the code in, what actually changed in this table from the previous code. Now, there were some changes in the total building performance pathway as well. The first thing that changed was that that the requirements to build to this code has changed because the language in the code has changed a little bit. They removed the term mandatory from the code and just replaced it with a requirement. And this was changed. I guess the best example would be if you look at attic eave baffles here. This is now the requirements table, and this attic eave baffle requirement comes from what used to be called the prescriptive requirements of the code. Now they're just requirements. So some people thought that when you utilized the building performance compliance option, because it is a performance compliance option and it didn't say mandatory by it, that you didn't have to install attic eave baffles if you built a ventilated attic space. Well, that wasn't the case. Just because it used to say prescriptive by it, it was a requirement that was required regardless of the compliance option that you chose. Because of that kind of confusion that some people had when reading the code, they got rid of the term mandatory, just made it requirements, and then in these performance compliance options, specifically R405 building performance compliance and R406 energy rating index compliance, they added this table to ensure that everybody knew that those things that were previously listed in the prescriptive section of the code are also mandatory requirements for this compliance option here. So that's a big one that we need to know about. The second thing that really changed in the building performance compliance option is that they introduced this notion of a backstop. So the backstop says that the building thermal envelope shall be greater than or equal to the levels of efficiency and solar heat gain coefficients of the 2009 International Energy Conservation Code. What this does is it limits flexibility and it limits our ability to trade off items. So builders aren't particularly happy about this, because this compliance option gave you the most flexibility to trade off R values for air tightness, or R values for duct leakage that was tighter, different ways of trading off your building specifications and still be able to meet the intent of the code here. But now you can't trade off less than the 2009 IECC. And you can see that in the R value and U value tables there, that things haven't changed that much. So you can't trade off less than an R20 wall, for example, in climate zone 5 here. But it's a big change, so you need to make sure that you're looking for that, especially when someone turns in the compliance reports. How are they actually doing the trade-offs? How are they actually demonstrating compliance, and what are the specifications that actually achieve that there? So in this pathway, reporting's been detailed out in a little bit more clearly, that you have to demonstrate compliance to get your permit for building the house. So there's a projected energy model that's done, and you need to demonstrate compliance at the end of construction. So that's the confirmed energy model that's done with the specifications that were actually installed. The projected ones, we're assuming that they're going to meet the air leakage requirement. They've told us that they're going to install, R20 plus 5 insulation in the exterior walls. If anything changed during construction, that's what the confirmed reports ultimately tell us to do. So this is an example of a report from a software called IECC that demonstrates the cost compliance metric for compliance with the building performance path. So if the cost of the as designed home is equal to or better than the reference home, so the reference home and the design homes are geometric twins of each other inside of the software. They use annual energy cost as the metric to demonstrate compliance. So this number of the designed house has to be equal to or better than the reference home. The reference home is overlaid with the code, what the code requires. The as designed is overlaid with the specifications that the builder wants to do, and see if what they want to do will work in terms of compliance. Will it be equal to or better than compliance? In this case, you can see down here that the design exceeds the requirements. In this case, it's based off of the 2018 IECC, but the same report is what you're going to see for the 2021 IECC. Those reports, or that software, has just been released by IECC and REMRate and some others that do these types of energy models, and that's why we don't have the updated 2021 report, but it looks exactly the same here, and it will give you the percent better than there. Also in this report, it's going to tell you what is the additional energy efficiency option that they have chosen here. So you want to look at that. Now in the 2021 IECC, in this pathway, the reference home is actually printed in the code book in a table in that section R405. And in that table, they created this new trade-off possibility, which is based off of having a more compact water efficiency design there, so that the hot water gets from the hot water heater to the faucet in the most efficient way here. Unfortunately, they didn't give any guidance for how to actually implement this trade-off in the software packages there. So we have not seen it implemented yet, and I'm not sure when it will be implemented here. So stay tuned for that, but you'll have to take a look sometimes at the reports that are submitted at the time for the building permit and for the certificate of occupancy to see if this new trade-off credit is being taken into account there. Okay, so the next compliance option is the energy rating index compliance option. So remember that the energy rating index in the IECC is not the same energy rating index that the ResNet HERS system is developing there. So you might get a home energy rating certificate from ResNet or the HERS home energy rating index turned into you, because often the people that are doing compliance or demonstrating compliance using the building performance path are also energy raters. And energy raters are giving this certificate to the builder, and the builder might be submitting it to the jurisdiction as well, even when they're doing compliance or showing compliance using the building performance pathway there. So make sure you're looking at the correct certificate. This is not a code compliance certificate. This is a marketing and informational certificate there. Now, the energy rating index score has changed over time. In the 2015, it was set in the 50 range. In the 2018, it was increased. And in climate zone 5, for example, it went from 55 to 61. And then in the 2021 IECC, the energy rating index that a building had to achieve has gone back down to 55. But remember that 55 means something different for the IECC energy rating index than it does for the ResNet HERS energy rating index score there. And those certificates, the HERS certificates, are not compliance certificates. In the 2021 IECC, backstops were incorporated into this section of the code as well. They've gone a bit further than the other backstops that were in the 2015 and the 2018 IECC for section R406. It begins by saying that if you have on-site renewable energy systems present at that house, it says that the building thermal envelope shall be greater than the levels of efficiency of the 2015 IECC. So you can't trade off below any R value or U value that's talked about in the 2015 IECC. So this is basically an insulation backstop that protects the building thermal envelope, but also limits flexibility to be able to develop specifications that builder might want to use when they choose to use this pathway in the code. And this is what the 2015 IECC insulation table looks like. And you can see that, for example, they couldn't trade off below an R49 attic in this case in climate zone 5 here, or an R20 wall assembly. So it's pretty significant, you know, for a builder who was used to building with maybe an R38 attic or an R30 attic because they didn't want to put in raised hill trusses to get that full coverage over the top plate, for example. The other thing that this section does, it says that for compliance purposes, any reduction in the energy use of the rated design associated with on-site renewables shall not exceed 5%. So this is a change from the 2018 in that on-site renewables can be used to slightly reduce the energy rating index score, but only 5% of that energy use. Basically, they're trying to protect the building thermal envelope and ensure that a poorly built thermal envelope can't be overcompensated by putting on a lot of photovoltaic energy in that house, because this compliance pathway is looking at all energy use, and all energy use from PV panels, from mechanical systems, all those things are reflected in the energy rating index score there. This section changes also in that energy rating compliance is talked about. It says that it shall be completed by an approved third party, which is helping to define who is actually generating the energy rating index score, because it's not going to be the code official, but there are other requirements that have to be verified in the field. So verification of compliance with the other requirements can either be done by the authority having jurisdiction or by an approved third-party agency here. It's very important if you are a third-party, if you are a jurisdiction and you're going to allow a third-party inspection agency to demonstrate compliance with how the insulation was installed or how the ducts were installed or any of those other things, that you have a clear conversation with that third party so that everybody understands what you're expecting of them in that inspection process there. They are being asked to do more than just generate the energy rating index score there. Approved inspection agencies has also been a little bit better defined in Chapter 1 of the IECC here, to say that code official is authorized to accept reports of third-party inspection agencies, provided that such agencies are approved as to their qualifications and reliability. So ultimately, the third party is working at the discretion of the code official there. And that's important to know, because a lot of people feel that there's a potential conflict of interest for the third party, because generally they're paid by the builder for that work. But remember, the jurisdiction holds the authority to approve their work or not. So a jurisdiction can basically say, you can submit documents to us, or you're not allowed to, and therefore they hold the power over that third-party inspection agency. And I believe that that ultimately smooths out what some people think of as a conflict between the third party and the builder, that they're ultimately working for the jurisdiction. They're not ultimately working for that builder there. Anyway, reporting has also been discussed in more detail in the 2021, that you have to demonstrate compliance at permitting and at that same stage certificate of occupancy here. So you want to make sure that you look at what reporting you need to review at those stages of construction and permitting and certificate of occupancy. Renewable energy credits are the dollar amounts, the value proposition for adding renewable energy to a house, and that is discussed, and that's new to section R406.7.3 in the 2021. So you want to take a look at that as well here. RECs can be sold on the open market. They are an energy commodity, and basically the code wants to make sure that the RECs follow the right course through it. Again, we're not going to talk about tropical climate zones, but these are all the things that are dealt with in the tropical climate zone. Chapter 5 is about existing buildings, and that they shall be required to be brought into full compliance with this code if you do an addition, alteration, or repair. There are some exceptions there, but when you deal with an existing home, make sure you delve into Chapter 5 as well, so you can see what changes might have been made there. There aren't super significant changes there, and existing home work still is very difficult to work with. Appendix RC gives you an option of adopting a zero energy residential building provision for your code. This one is slightly different than the energy rating index pathway. It is using an energy rating index pathway, but they didn't amend the 301 standard that governs how an energy rating index is created in the body of the code here, in the body of this appendix. So this energy rating index is equivalent to the ResNet HERS energy rating index, whereas in section R406, the energy rating index was amended in the language in that section of R406 specifically for ventilation, and that's why the scores are not equal to each other there. So you want to make sure you understand that. There's no ventilation amendment in the appendix, therefore it's equivalent to the HERS energy rating index score there. The building shall also meet the requirements of the table R406. So those are all the mandatory, in essence, mandatory requirements in the prescriptive section, the old prescriptive section of the code, as well as in the air barrier, air sealing, and insulation installation section of the code as well here. Okay, so we have the second half of what we're going to talk about today are changes that don't impact efficiency. So there's some administrative changes that have happened in the code here. And this administrative section of the code is always worthwhile to look at because there's some important things that are in here. So the biggest thing here is that we have a clear understanding of what are the construction documents versus the compliance documents. Now, the construction documents shall be prepared by a registered design professional here. So those are the actual engineering documents, the plan set for the wall layouts and the room layouts and how the building's actually going to be constructed. Those are documents that are created by architects and engineers. Those are the registered design professional. The construction documents include proposed and confirmed compliance documents for the area weighted U value pathway, the building performance pathway, and the energy rating index pathway. Also air leakage and duct leakage reports or ventilation testing reports that are turned in there. Those are reports that don't have to be created by a registered design professional. And we're seeing all kinds of individuals, approved third parties doing it, energy raters doing it. Sometimes HVAC contractors and insulators are also submitting documents, specifically the area weighted U value report there as well. Also in section 302, the details that need to be included on the construction documents that are created by the registered design professional need to now include the energy compliance pathway that they are using for demonstrating compliance. Is it the prescriptive R value table, or is it the building performance pathway? You need to know on those construction documents. Something that hasn't changed for a while, but is often not looked at and enforced very well, are the air sealing details that are required on the construction documents. Air sealing details are details like these that demonstrate where the air barrier needs to be installed, that demonstrate that the framer is really responsible for about 90% of the air barrier details in the code, and these details need to be transferred from the architect's mind to the actual framer that's framing it, so that they know that they need to put up the air barrier to the bottom cord of the truss and the air barrier to the exterior wall before they do the overframing for this drop ceiling for this can light, so that this whole drop ceiling is brought into the conditioned space of the house. Where this helps as well is the other requirement in section or chapter 1 that says that the building thermal envelope shall be represented on the construction documents. This is just one example of how that's done. You'll usually see it on the sectional drawings and hopefully on a couple different sectional drawings of the house. The idea here is that we're trying to ensure that we have continuity of our building thermal envelope. And remember, building thermal envelope is a defined term in the code. It's an assembly of things, particularly our air barrier systems and our thermal barrier systems there that are separating, giving us a clear separation or boundary between conditioned space and unconditioned space. Super important to understand that and that concept is being translated out into the field. Inspections are talked about as well in the 2021 IECC. All these different inspections that have to happen, and they get translated into some things that have to happen specifically for the energy code. For framing, we need to verify the R values and their correct location, but also their proper installation. Is it there and does it work? It reminds me of what Michael said in the introduction here. Air leakage controls are as required by the code. On the mechanical section, just an example here, required to look at the controls, the system's installation, and corresponding R value. So what is the R value of the duct that's located in that ventilated attic? System air leakage control, as well as whole house controlled mechanical ventilation. So remember, we're talking about building our houses tight. We're talking about ventilating them correctly for the house. It's a sound building science principle that's now been codified in the code. It's been codified in the code for quite some time. The 2021 continues to write it better and bring it forward in a different way here. So when we're looking at houses now, when we're inspecting houses now, we can't just walk into that house and say, yep, I see a bath fan, it's in the right location, I'm going on to my next inspection. I actually now need to look at how that bath fan was installed, and is it actually going to work the way it's been installed here? Has the insulation been installed? Has it been installed in such a way that it actually functions and works here? In this case, in both these cases, it's there, the requirement is there, insulation is in the cavity, but it hasn't been installed in such a way that it actually functions and works. Same with our HVAC systems. We need to go a little bit deeper to make sure that it's going to function and work as required by the code here. So one of the big things to understand with regards to the requirements in the code is that there are requirements and there are R values and U value requirements. R values and U values can be traded off. Other installation requirements can't be traded off. So installation requirements have to be looked at regardless of the compliance pathway. R values and U values are things that can be traded off. And I think we talk about trade-offs here in just a minute here. Definitions have been added into the code and or revised in the 2021. So you want to take a look in the definitions chapter, chapter 2, and make sure that you have a common understanding of not only those key things like air barriers and continuity of air barriers of things, but maybe thermal distribution systems or dwelling unit enclosure area, which becomes very important now that we have a CFM per square foot of shell area or enclosure unit area as a metric for demonstrating whole house air leakage compliance. So we're not just relying on air changes per hour anymore. We're using dwelling unit enclosure area, which is a much better area, especially for smaller dwelling units here. Chapter 3 deals with design temperatures as well as climate zone issues here. So it's defined our interior design temperatures, a maximum of 72 degrees for heating and a minimum of 75 degrees for cooling for that. So it's setting up the delta T location for our HVAC design work so that we have properly sized heating and cooling systems in our homes. Chapter 3 also talks about the building thermal envelope and the insulation. The insulation installer shall provide a certificate listing the type, the manufacturer, and the R value of the installed insulation for each element of the building thermal envelope. We are getting that for the most part for our attics, but we are not getting that for the rest of the insulation that's installed in the house. So in the 2021, this was clarified to make it more clear that for insulation materials that are not installed or that are installed without an observable manufacturer's R value mark, the insulation certificate shall be left immediately after the installation by the installer. So in essence, the installer now has to certify the R value of the material that they installed, because I can't look at any of these materials at inspection and tell you what the R value is. The insulator needs to do some level of quality assurance on their install, especially if they're doing a blown cellulose or a blown fiberglass or even a blown foam material, to document what is the R value of the material that they actually installed. But there are other materials like these fiberglass bats that theoretically have an R value mark on it, but they're very difficult to find, or these vinyl faced fiberglasses that are used, at least here in Colorado, for unfinished basements. I can't go and look at I can't determine what the R value is. So the code is saying, insulator, you've got to certify what you've installed. You got to leave it for inspection so that all parties understand how you're actually meeting the intent of the code. I'm going to jump to section 4, chapter 4 here, because this certificate is also required here. You have to demonstrate compliance, and you have to put the certificate in the house so that it's basically documentation that should live the life of the house there. And there's some additional things that have been added to the certificate specifically for photovoltaic PV panels. The energy rating index score, if there is one available for it, needs to be on the certificate. And other compliance options need to be demonstrated on the certificate. Remember, if you're showing compliance using the using the R value table, for example, you might see a certificate like this generated by hand by the builder or the insulator, because there isn't a software that's used to demonstrate compliance for that compliance option there. So there's no software that can print out the certificate for you there. And I can, if anybody's interested, I can show you an example of that certificate. It basically looks like that other one. Chapter 4 is where we get into these compliance options and the actual requirements there. The additional energy efficiency package that we talked about here impacts kind of the implementation of the code as well as the efficiency of the code. So that's why it's kind of redundant here and shown twice here. But what I really want to get at is that this word mandatory has been deleted from the code, and therefore we need to think about the terminology that is used now in the code. So mandatory was just an adjective that was describing requirements. Requirements, in essence, are mandatory, but they're mandatory regardless of the compliance option that you're using. So mandatory requirements meant items that could not be traded off. Requirements must be met by every compliance path unless there is a specific exception written in the code. If you don't see a specific exception written in the code, then it is a requirement and it needs to be installed and it needs to be inspected for compliance there. Now, prescriptive requirements are requirements that can't be traded off in most cases, but must be met when using that prescriptive section of the code. So when you're looking at the 2018 IECC, for example, you'll see that there's prescriptive and mandatory written next to the code. But prescriptive requirements are also required by the performance options that are available in the code. And therefore, you need to ensure that you're looking at all requirements now. And in the 2021, that's been made significantly more clear that requirements are requirements regardless of the compliance option here. Now, when we talk about performance approaches in the code, this allows the use of trade-offs to meet specific prescriptive R-value requirements of the code that ensure equal or better performance. A performance approach doesn't override any requirement in the code there, and you can trade off R values and U values. You can trade off air tightness. You can trade off duct leakage depending on the compliance option that you're using there, but you can't trade off a requirement. So the problem that is still in the code is that some requirements embed R values into the requirement. So you can trade off the R values and U values, but if it also talking about how you install something, that is something that is a requirement that you can't trade off here. So remember that in the R405 and R406 sections, this requirement table has been added to the code that includes the R402 requirements that used to be labeled as prescriptive, and make sure that those are requirements that will get implemented if you choose an R405 or R406 compliance alternative. Now, this is an example of a requirement that mixes up R values and also installation requirements here. So I'm going to read it as if we're here in climate zone 5. So it says R49 shall be deemed to satisfy the requirement of R60 wherever the full height of uncompressed R30, or it should say 49, insulation extends over the wall top plate at the eaves. So the R value is something that could be traded, and in theory, you could trade off all the way down to maybe R30, R10, something much lower than R49 over the top plate. The installation requirement is that the full height of whatever insulation you install extends over the wall top plate there. If you were following this section in relationship to the R value table compliance alternative, then it says I could drop down to R49 or R38 insulation from the higher level that's called out in that table, as long as that full height of insulation covers the top plate there, which also means that you're probably going to have to use a raised hill truss in order to achieve that there. The raised hill truss is something that a lot of builders are not interested in doing, and that's why they might move to a trade-off approach, like the U-value trade-off approach, to see if they could get compliance using an area-weighted U-value at a lower R value, and therefore they could use a smaller raised hill truss or potentially not a raised hill truss at all. Hopefully that makes sense. Eave baffles. are defined better in the 2021 IECC. And the big difference here is that if you have skip soffit ventilation systems, you now have to install your eave baffle continuously to ensure that the soffit ventilation air is not bypassing the soffit baffle there and integrating and impacting the insulation that's been installed in that attic, so that doesn't perform well there. So we want to make sure that everything is installed and installed well. This type of installation, the picture on the left with the bats down here, is simply an installation that does not meet the requirements of the code because the baffle doesn't come down to the top plate. This insulation here, this fibrous insulation, doesn't stop the movement of air here. This installation might or might not work depending on your compliance option. Again, if you're going to go to this little bit of insulation that's over the top plate, it meets the requirements of insulation being over the top plate, but doesn't meet the requirements for the R value, either from the R value table or the trade-off R value that you might install over the top plate there. So you need to look at those things. Attic hatches have been better defined in the 2021 IECC so that the R value is required for that attic hatch equals the R value of the ceiling it's penetrating or the wall that it's penetrating there. If you have attic platforms, you have to get the full height of insulation underneath those attic platforms. Attic hatches need to be airtight and air sealed attic hatches there. Floor assemblies have been better defined in the 2021 IECC. You have 3 options for how you install floor insulation, and you need to take a look at those 3 options there. I can tell you option number 2 and 3 are very difficult to inspect in the field, but they are allowed by the code. Basement walls, if you see basement walls in your market there, what's nice about the redefine in this section here in the 2021 is that we clearly are defining conditioned basements versus unconditioned basements and how you deal with each of those to get an insulated building thermal envelope. Slab on grade floors are dealt with as well in the 2021 and have been redefined. Specifically the depth below grade that the slab edge insulation needs to go from the sill plate downward. In climate zone 5, for example, we now have to go 4 feet down instead of 2 feet down. It all needs to be protected. And what we're seeing is that using the foam insulation as a replacement for the expansion joint is the best way that builders are successfully meeting the intent of this code, because if you move the insulation to the outside, you also have to bring that insulation above the dirt level of the exterior grade, and therefore you have to deal with how are you going to protect that insulation through construction and then after construction, and that's a difficult detail here. So the code gives you a variety of different ways to do that. Sunrooms and heated garages are dealt with in the 2021. So this R402.2 section, there are 12 requirements that are listed now that the word prescriptive have been scraped off of it, and now they're just requirements regardless of the compliance option that you're using. The air barrier and air sealing and insulation installation table, the name has changed, but also these sections in that table have changed as well. So you want to go into this table and understand the requirements that have been updated. Generally, the language has been changed. The requirement really hasn't changed. It's just making it more understandable about how you actually comply with this table. And remember that this table is a requirement. So things like insulated headers and insulated corners, those thermal bridging details, those thermal bridging requirements are required regardless of the impact. And we are not enforcing that well. Blower door testing has changed as well. This is an unfortunate section here. It says that the building shall be tested and that the maximum air leakage rate for any building shall not exceed 5 ACH, or that the 0.28 CFM per dwelling unit enclosure area. So first, this second metric has been added to the equation because the first metric, the ACH metric, is a volumetric measurement, and it becomes very difficult with small volume homes to actually achieve this. This is specific to section R405 and R406, because theoretically you could trade off for a more leaky building if you have more R value in the building's thermal envelope. It's not really how trade-offs generally work. People are more apt to build a tighter building envelope to put less R value in a specific assembly in the building, but some people were worried about trading off in the other direction and having a very leaky home here. Although this is specific to R405 and R406, they forgot to mention that specifically in the language of the code here. So you want to make sure you understand what this section is actually talking about. It's talking about trade-offs, and specifically for the R405 and R406 section. This whole testing section continues and says that you can use that CFM per square foot of enclosure area if you have an attached single family or multifamily building that's 3 stories or less, and you have a dwelling or you have a dwelling unit that's 1,500 square feet or less there. So you want to take that into account. And also, this is where we get back to the actual requirement of 3 air changes in climate zones 3 through 8, or 5 air changes in climate zones 1 through 5. So that hasn't been amended. Those are still the requirements. It's just if you're utilizing the trade-off mechanism of air tightness in R405, the building performance path, or R406, the energy rating index pathway, you can't trade off beyond 5 air changes there. Electrical communication boxes are talked about here because you have to have an airtight box. You can make it airtight, a typical box, or you can use this airtight box in your homes there. Duct leakage is talked about. Basically, the diameter of the duct indicates the R value of the material that needs to be installed. And this section now deals with duct location, and if the ducts, and trying to define the duct location as if the duct were inside the building envelope. This is important again for section R405 and R406. If I can determine that the ducts are inside the building envelope, I have a little bit more ability to do trade-offs for lower R values in my building thermal envelope there. So you want to look at this if someone's taking advantage of those trade-offs. Ducts located in conditioned space is also defined for ducts that are located inside of building assemblies. So ducts that are located in a floor system over a garage or a wall, an exterior wall, for example. You would want to look at these sections as well. We're going to go fast through this because I've run out of time actually here. So you want to look at that if you have ducts in a floor system or a duct in an exterior wall. There are installation criteria here so that you can determine if that duct should be modeled as if it's inside the conditioned space or outside the conditioned space. And then if it's up in an attic and they bury the duct in insulation, you might also be able to claim that that duct is inside the conditioned space here with deeply buried ducts. That section of the code where it's talking about deeply buried ducts. Duct sealing is still required. Duct testing is still required. The big thing now is that ducts shall be pressure tested regardless of their location. In all the other codes, if any portion of the duct was outside the building thermal envelope, you had to test the ducts. Now you have to test the ducts regardless of where they're located. But if they're located if they're all located inside the building thermal envelope, the duct leakage requirement is relaxed a little bit. So you can leak as much as 8 CFM per 100 square feet of conditioned floor area. For that 2,000 square foot house, it goes from about 60 or 80 CFM of leakage to 160 CFM if all the ducts are located inside the building thermal envelope here. This trigger for ventilation that's based off of air tightness has changed a bit in the 2021 IECC, but it's actually in the IRC where you want to look for that change, not in the IECC here. So you want to look for it there. And ventilation rates here. Heat recovery ventilators are now required, are mandatory in climate zones 7 and 8 there. And mechanical ventilation systems, there's some requirements that if you're using your furnace system to ventilate the whole house, you have to have an ECM motor here. I'm gonna jump over this section so that what I ultimately want to get at is that this is a brand new requirement in the 2021 IECC that you have to now test for the flow rate in our bath fans, our kitchen hoods, and our whole house mechanical ventilation systems, because that flow rate is a specific requirement in the code, and we're not achieving it there because of how we are ducting these fans here. Lighting equipment is also a big change in this code. All lights have to be high efficiency lights or high efficacy lights. There are now requirements for lighting controls on the interior of the house and lighting controls on the exterior of the house. So sorry for going over just a little bit here to give you those significant changes here. What I like to say is that is just reiterate what the Dalai Lama says. The Dalai Lama says you need to learn the rules so that you know how to break them properly. From a code perspective, learning the rules means understand the written language in the code so that you understand the flexibility that's been built into the code so that you can take advantage properly of trade-offs to keep the balanced equation of what's being traded off for what the code is actually requiring and that level of efficiency that the code is actually requiring. Trade-offs give you that ability, but it's also requiring that you have the same or better energy efficiency that's dictated by the code there. So thanks so much for your time. Sorry it was a little rushed at the end there, but if you have any questions, I'm happy to stick around and talk through anything that might have been confusing.
Thanks, Robby. We appreciate it much. And we do have some questions coming in, as well as questions that already did come in. So I'm going to go ahead and harken back to some of the ones that came in already. Interesting question from Drew. He asks, why isn't orientation considered, like having credit for south-facing windows or certain facing windows?
Yeah, so traditionally the code is being developed as it traditionally has been, and the code is kind of myopically focused on the building thermal envelope. And so that means it's myopically focused on R values, U values, and tightness, air tightness of that building thermal envelope as the primary means of energy moving in and out of that building thermal envelope there. So even when you get into the energy modeling for that compliance pathway, mechanical efficiencies aren't included in that in most cases, except when you get into the energy rating index pathway. And house orientation isn't part of that there. It makes total sense that at some point that gets added to the code, but it would require somebody to make a proposal to change the way that energy modeling is used for the code and to justify that change basically for the code to develop in that way.
Okay. Robby, I had a question for you. You were talking about renewable energy credits. What happens in states where those aren't a thing?
Then you don't have to worry about them from the perspective of a code. Yeah.
Okay. Okay. So the AHJ doesn't have to amend that out. It's just there's language in there that says, hey, if this doesn't exist in your state, then just disregard.
Yeah. In most cases, the code is only a requirement if you've installed something. You know, the best example of that would be a drain waste heat recovery system. There's some requirements that are talked about in the energy code, but they only become a requirement if you install that. So they're not saying you have to install a drain waste heat recovery. They're not saying you have to install photovoltaic panels there. And if that state doesn't have a REC requirement, then you don't have to implement that section of the code. You could amend it out as well.
Yeah. Okay. Connor wanted to point out that RC 102.2 references ANSI ResNet ICC 301, but not 301 and the min-HERS, which is what the HERS index is. And so.
Yes. So what I was saying was that it references ANSI 301, and it also, which is also the standard that ResNet HERS is using to generate their energy rating index. It doesn't, in the appendix, amend that standard, whereas in R406, they actually amend the standard's ventilation requirement in the body of the code there. And that has caused the energy rating index of the IECC and the energy rating index of that is normally created with the 301 standard to diverge from each other. The scores are not the same for the same house. Now, what Connor is getting at is that sometimes ResNet ResNet is kind of the governing body that works to amend or is the, how do you say it? They do the upkeep of the standard 301 in each of its cycles. It's a 3-year cycle as well. And ResNet sometimes adopts amendments to the 301 standard before it's become official in the 301 ANSI standard there. And that potentially could change the energy rating index as well there.
So the Secretariat, is that?
It's kind of too technical probably for what we're doing, yeah.
Okay, the question came in from Justin. For the, again, we're talking about RC 102.2. With all that's factored in there, does this mean that off-site renewable energy can be included in the energy model?
If they adopted the appendix, you have to achieve a certain energy rating index for your climate zone before PV or solar is added to the home, and then you achieve 0 with adding PV to the home. So basically the energy rating index score, you can't get to 0 just with maximizing your building thermal envelope and your mechanical efficiencies. You can only get to maybe, the lowest I've seen is about a 35 on the scale. Everything from 35 below to 0 is done with PV panels.
Right, but his question is talking about off-site renewable energy.
Oh.
So community solar, or as he says in his question, how about a green power purchase agreement rider on a residential utility service?
Yeah, right now, according to the appendix, no, because the energy rating index only addresses things that are attached to the house or are physically on site. If it was physically on site on that property address, you could take it, but you couldn't use off-site solar garden there unless the jurisdiction amended the code in some way.
Okay, okay. Robby, by the way, people should take note of Robby's contact information there. It's on the screen in case they have further questions. The last question we've got here, I'd ask that you kind of roll back in your presentation some. It comes from our friend Fernando, who's in Puerto Rico, and we have a couple other people here who are from tropical areas. he said that, you know, look, I get it, you know, tropical code compliance path is not a core item for you today here, but he wanted to know if you could maybe show the relevant slide again, and also give us just a little summation of what are the major issues that maybe you see within the tropical climate code compliance path.
Well, I can do the first part of that, I think, which is to show the slide. So hopefully you can see the slide now. The second part, you know, to be quite honest, I can't, because the tropical climate zone is irrelevant to my location here in Colorado, and to be honest, I haven't studied it. But that gets back to the Dalai Lama's statement. You need to learn the rules in order to break them properly. So study this section for your tropical climate zone, and you will learn the rigidity of the section and also where the flexibility is built into it.
Now, Robby, the tropical climate region, it's not brand new, but that just got introduced into the code in the past couple cycles, if my memory serves me correctly.
I believe it's brand new to the 2021 IECC.
Okay.
Yeah.
Okay. Okay. I knew it wasn't old. I knew that.
Zone 1 before, but they didn't really have this true tropical climate zone.
Right. Didn't they at one point try to call it climate zone 0?
Yeah, I believe so.
Yeah. Yeah. Okay. All right. Well, I don't see any other questions. And by the way, that question came in from Fernando, who's in Puerto Rico. And he's a friend of the webinars. He attends a lot, and they're also going through a lot of disaster recovery right now. So the code is super relevant to what they're doing as they're rebuilding down there. So we're thinking about you, Fernando, and understand that you know why you're seeing this be so important.
For sure, for sure.
Well, we don't have any other questions, so I am going to wrap it there, Robby. But really, thank you so much for coming on today, last minute, to talk about this. And love the presentation. I got to see you out at EBA, as we talked about earlier, and you went through a lot of this there too. And it was a very good session there. So appreciate your time today, bud.
Okay, good to see everyone, and thanks for having me.
Yep. Thank you also to our audience for asking all those wonderful questions, and also to PowerShift by NV Energy for their generous sponsorship. Now, you want to check out any part of this presentation again? Well, good news. It's going to be on Green Builder Media's YouTube channel, and you'll get a link to that recording, and also a PDF of the slides will be distributed via Green Builder Media to all registrants as well. We're going to be back in about a month. That's when Sarah Gutterman is going to join us to deliver the State of the Industry address. That's going to take place on Wednesday, December 7th at 2 p.m. Eastern Time. And I hope you'll join us. That'll be our final webinar for 2022. Until then, have a great Thanksgiving, and we'll see you in December. Take care.
Take care, everyone.